Can you see my screen, Dr. Chen and Dr. Yin?
Yes, I can see.
That's nice. Okay.
Yes,
So,
I can see one.
okay, cool. So thank you so much today for being here. I have like Dr. Pan, Dr. Wilfer, and Dr. Han on site. I have Dr. Chen and Dr. Wen online. So I'm so excited to have you today. So I will do my defense. The title is Machine Learning and Unstructured Data Analytics for Digital Marketing. So this is the outline. I will first introduce some concepts related to marketing and unstructured data, and then introduce some basics about machine learning, since we're a mix of like engineer and marketing people here. And following that, I will introduce three works where I apply machine learning to marketing problems. And last, I will do conclusion and future work. So first, what's marketing research? A very authoritative place like named American Marketing Association defined marketing research as a function to link consumers, and the public to marketers through information. So the information here is what we as marketing researchers, we try to find. So what information we need? We need information to find the opportunities to develop like new product. We need opportunities to seek like consumer needs. And with those opportunities, we need take actions for we need recommend actions for marketers. Like when should we like do those coupon distributions? When should we like do those advertising to different like consumers? So after marketers take those actions, it's also crucial to monitor the performance of those actions, right? So it's very like key to the business success. But in marketing, there's a lot of information. We need to improve our understanding to those different like steps we took toward our business success. So this is also the biggest like difference I observed during my PhD study between like engineering and marketing. So usually to do this, we need the knowledge from like psychology or sociology to understand those each steps. So to do this, traditional marketing researchers usually analyze structured data. So for structured data, such as those sales figures, those demographics information, those survey data. So those types of data are usually organized, well organized in rows and columns, such as in those BigQueries or Excels. But due to the prevalence of mobile devices and the social media, we know there's a lot of like unstructured data online every day posted on like those TikTok or Instagram and Twitter. So those unstructured data includes those like text, images, videos. So for those textual, those unstructured data, if it's posted by like users or consumers, we call it like user-generated data, like those product reviews on Amazon. So if those data are generated by companies and firms, we call it like firm-generated data, like those images posted by those fashion brands on Instagram to promote their like new products or generate awareness. So for those types of data, as marketing researchers, before we can perform any statistical analysis, we need to like code those data. So usually we need manually or find some automatic tools to do the coding. For example, if I want to examine the sentiments in the product review, I need to code like whether it's positive or negative as positive as 1 or negative as 0, etc. So for this step, imagine we have a huge number of data like online. It's very time inefficient for like traditional marketing researchers. So this is a big challenge I want to address during my PhD study. Specifically, we know machine learning algorithms are very like efficient in processing large data after we properly train those models. For example, for images and video data, we can apply those computer vision algorithms to understand what's going on in those images. For example, here, for those user posted images on Yelp, we can classify whether they're healthy or unhealthy. We can also link those like to those brand associations for more like brand management. Another example is that we can also use like computer vision algorithms to understand and predict the gestures of those athletes, so we can better like do those sports management. For text data, we can also use those natural language processing algorithms to do those like sentiment analysis from those product reviews. Yeah. So During my PhD study, I mainly apply different machine learning, computer vision, and natural language processing techniques to analyze unstructured data in marketing. So till now, I focus on three substantive marketing problems. The first one is online and mobile advertising. The second one is diversity in marketing communications. And the third one is social media marketing. So across those projects, I apply eye tracking, I do like those Python programming to collect those web data, also design experiments to collect those survey data, also collaborate with those companies to collect the first party data. So with those data, I next will apply those algorithms to understand those features in those images or videos. With those features, I next usually will build those statistical model or Bayesian analysis to do those statistic inference. The goal is we can provide more actionable insights for those advertisers or for brand managers. Any questions so far? Okay, cool. So next, I will introduce my first work. The full title is Understanding Consumer Visual Attention in Mobile Advertisements, Ambulatory Eye Tracking Study with Machine Learning Techniques. So this project is funded by the 2021 Amazon Research Awards. So till now, as you may know, these research awards are usually like granted to those computer science or engineering people. So far, it's like only 4 to marketing researchers. And a little bit motivation why we focused on mobile advertising. We know in recent years, nearly everyone got smartphones on hand. A direct result of such prevalence is that not only in last year, 30% of online US written web orders come from smartphones compared to only 38 from PCs. And accordingly, mobile advertising expenditures also increased a lot. In last year, there's about 73.5% of ad expenditures have been on smartphone platforms, which is like more than 2 times of that on PCs. So this give a very interesting question is that as marketers and advertisers, we're really interested in like how do consumers visually attend those mobile advertisements as it's so popular. So one way to do so is through eye tracking technology. When we do literature review, we find in previous researchers generally focused on PC advertisements. To do this, they also used fixed eye trackers as shown in this figure. So usually fixed eye trackers, there's a camera mounted in on the screen. But when we do eye tracking research on mobile devices, imagine when we when we do shopping on smartphones, smartphones is too small. Like we cannot mount any like more cameras on that. So we need to use this portable eye tracker as shown. Okay. Yeah, as shown on left the bottom figure. So participants usually wear these kind of wearable eye trackers when they do those shopping. But one quick challenge is that for example, if a customer is looking at these hotel advertisements, this red circle indicates his eye fixation coordinates. So during the shopping, the eye trackers can record the coordinates of the eye fixations, but the eye trackers does not tell us what objects it is. So usually researchers need to draw this rectangle to see, oh, this customer is looking at the texture information. But when the eye fixation like moves to another place, researchers need to drag this rectangle to another place. This dynamic process is very time consuming. So this is one challenge. Another challenge is that the objects, the size of those objects on smartphones are too small because the mobile screen is small. So to address those challenges, we motivated with these projects. A little bit more study context, we will focus on hotel shopping, and we specifically interested in understand customers' attention patterns across 2 types of variables. The first one is textual ad elements versus pictorial ad elements. So for the left-hand side, it's the screenshot of the PC web hotel advertisements. We see we have 4 areas of interest. On the left-hand side, it's the hotel image. In the middle is the hotel texture information. On the right-hand side is the price and rating, similarly for the smartphone layout. So for text, rating, and price, they're considered as textual messages. For images, we consider it as pictorial ones. So the second variable is mobile advertisements versus PC advertisements, since the previous researchers usually focused on PC advertising, but in this study, we focus more on mobile advertising. So we really want to know whether there's a attention difference between those two platforms. So to understand how consumers allocate their attention to those elements, we propose to build our hypothesis based on the theory of attention. So James classified like people's attention include two types. The first type is bottom-up attention. The second one is top-down attention. So the stimulus salience affects dominates the bottom-up attention. The size and layout affects the stimulus salience. For example, a bigger size like front attract more attention compared to a small sized objects, and compared to those like rectangle layout, those square layouts attract more attention. So in our study, we can tell that on the PC web, the images are in square layout. But for the mobile advertisements, the images are in a rectangle layout. So another route for the attention is top-down. The informativeness of those ad elements affects the top-down attention, but the informativeness also depends on our goals. For example, when customers are doing like online shopping, they pay more attention to textual information compared to imagery information. But when they do those like ad evaluation, they pay more attention to those images because it's more easily to do to remember them. And so based on those, we do three hypotheses. In the first hypothesis, we posit that textual information receive more attention than pictorial ones when customers do online shopping. And in the second hypothesis, we assume that mobile advertisements receive less attention compared to PC advertisements between it's too small. And the third hypothesis about the interactions between the types of device, the type of shopping device, and the type of ad elements. So our methodology to answer those hypotheses includes three steps. In the first step, we do data collection with a portable eye tracker. In the second step, that's where we apply object detection to detect the locations of the different types of ad elements. So after this step, we do the match. That is, we match the eye tracker recorded eye fixation location with our detected locations of areas of interest, so that we can know in each time step, a customer is looking at which object and for how long. So yeah.
Do they see like one ad at a time, or is it like a search result?
Search results.
Search.
They're browsing the search results. Yeah. So to specifically disentangle the challenges on detecting objects on mobile devices, we further propose this two-step YOLO, that object detection. That is, we add one more step, which is to extract the locations of smartphones from those advertisements so that we can make the perceptions of those ad elements more larger. So this is a two-step YOLO. So in the first step of our methodology, we do the data collection. We performed the PC-based eye tracking experiment in 2019. Here we recruited 53 subjects in our University of Houston. So here each participant was required to book a hotel in either Austin, Texas or Hawaii. So in total, we collected 81 eye tracking videos. In 2021, we did a lot of experiments focused on smartphone shopping. At this time, we recruited 79 subjects. They focused on same like hotel destination. At this time, we recruited 154 eye tracking videos. So with those data, we randomly sampled some video frames to do our model training, and then we find that the one-step YOLO on PC devices had a high performance of mean average precision at 94.5%. On the smartphone device, it achieved a high performance at 86 and 6%. Our model also had a very time efficient, and one person, like to annotate one video frame for a person, it took like 30 seconds for us. But for our the machine learning model on the PC device, it only took 0.08 seconds, and on the smartphone setting, it took 0.2 seconds. So it's way efficient than human annotator. So at the third step, we do the matching. That is, you see here the red circle here indicates eye fixation coordinates. Those rectangles indicate the detected locations of different like add elements. So we match them if the eye fixation is located within one rectangle. After this, we can compute how long a customer is look at each area of interest and for how many times. Those are called eye fixation count and eye fixation duration respectively. So after this, we build our statistical model to answer our hypothesis. Here, the Yij here represents participant eye fixation count or duration on an area of interest in shopping session J. The beta 1 here is our first focal coefficient that's used to answer hypothesis 1. The for area of interest here, AOI image is the reference group. That means if the beta 1 is positive and significant, that means those consumers pay more attention to textual information compared to pictorial ones. The beta 2 here uses to answer hypothesis 2 to compare the attention between mobile and PC advertisements. So if the beta 2 is negative and significant, that means mobile ads receive less attention than PC ads. Similarly, for the interactions between those two variables, we have gamma. Here is the focal coefficient. And the X here include a set of control variables, include gender, age, destination type, and shopping time. So we used list order to do the estimation and find that. Interestingly, if we look at the results on eye fixation count in the left two columns, we can see that the estimated coefficients of areas of interest rating and text, they're positive and significant. That means those textual elements receive more attention than pictorial ones, supporting our H1. And if we look at the device on mobile, the coefficient is negative and significant. That means mobile advertisements receive less attention than PC advertisements. When we look at the interaction terms between those two variables, we will find that those three coefficients are positive and significant. That means mobile devices have a positive moderation effect on people's attention to textual elements versus PC ad elements. And if we look at the right two columns for eye fixation duration, we will find a consistent results. So
I have a question.
yeah.
So you say that the text receives more fixation and more like longer duration
Yeah,
compared to images, right?
yeah.
So how do you know if that makes text more important than images? Or is it just that it takes people longer to process text than it is to process images?
Yeah, that's the nature, right? When people process text, like they would use more time. But in reality, for the importance, like the attention is one measure. We can use the attention as the like surrogate for importance, right? So if those customers pay more attention to an element compared to another, we would assume it's more important to them since they look at it like for longer. That's also one aspect we can provide insights for those advertisers.
Probably we need to kind of, in the future work, we probably need to normalize. Because when we have a kind of image, okay, how many seconds that our brain react. And if you look at the certain length of the text, how long our brain will react.
That's a good search. Actually, in our study, we controlled the size of the elements. Yeah, we control the size.
I think either in psychology or science, probably you can find some reference paper about what the concept.
Yeah, we do use normalization about those eye fixation.
It's not only normalization, find some evidence from the reference paper.
Oh, to support
in
those.
those areas. So yeah,
That's why I was asking, because there's some evidence that says that we're quicker to understand images and product
Exactly,
images,
that's my
Yeah.
understanding.
right?
So,
Yeah.
but I think the problem here is a little different. For example, if you check the hotel, probably the room picture got the second, the price got first. That's
Yeah,
not
yeah,
what the case
yeah.
for me, at least.
But it would be interesting to like disentangle it.
Exactly.
Yeah, less suggestions. Thank you, Hais. And so Alex, actually we did an additional analysis because our committee during my proposal like suggests I do this. So actually we did this. Specifically, we split each shopping session into two groups, from the start time to the middle and from the middle to the end. In this case, we try to explore whether consumers' like attention distribution will change over time during their shopping. Actually, we find very interesting thing is that after we control those ad elements and shopping device type, we find positive and significant coefficient for the shopping progress. Here, the 0 to 50% is the reference group. So these positive coefficients means people pay more attention to advertisements when it's close to their decision-making stage compared to in the early stage, like the search product candidates in those search result page. So this is allows her like additional finding. A summary of this work, we theoretically propose like one step and two step YOLO to like tackle those challenges of detecting those ad elements, including both textual and imagery. We extend our understanding of the theory of attention and consumer search domain. Our findings definitely can provide actionable insights for online advertising platforms like those Booking.com, hotels, and their layouts. Interesting, their PC layouts for images is square, but for mobile devices, it's rectangle. So this is a very interesting finding.
So could you show us the diversity of people participating in this experiment?
So actually, we controlled the gender and age, but due to the limits, I didn't report the results of those control variables, but I just directly reported the main results.
Yeah, exactly like our discussion, probably 2 minutes ago. It's really depends on the
People.
People, the diversity. For example, if
Yeah.
samples are most of them are students, like I said, probably they pay attention to the price more than the picture.
Actually,
against the the intuition. If you, I don't know, probably a sample more people middle age, older guys. They're more to the picture than the
And
price
it
itself.
depends too, right? If you are looking for a hotel for personal travel or for business travel.
Exactly, yeah, you can
Oh.
reimburse.
Actually,
you
Yeah,
can,
exactly.
you always.
If you just got a nice grant. you know.
Yeah. Because
So,
of presidential.
we
speech.
do have the findings actually, but for the destination type, we didn't find any significant results. But for the gender, we do find. In our initial analysis of this research, we find like female participants pay more attention to those images, but male participants pay more to the textual information. But in our final round, we didn't include those in our paper, but because it's too much.
Data collection. You know that we can only have the free sample from the peer.
No, yeah.
Or we go out, you know, that for the student, I mean, $25 and the blah, then we can get it. And for the rich people or something like
I
$25.
don't care about that.
But you can think about it like when you split it up in the bottom up and the top down, you can argue that the bottom up doesn't depend on the viewer. And then top down, the goal determines what you're gonna.
Yeah, true.
It would be very interesting to see.
Yeah.
For different kind of travelers, if they really direct their attention differently.
Yeah.
But
That's
let's follow.
interesting.
We can start a follow.
Too many possibilities there, so.
I know, that's always difficult.
Yeah, and also, you know, that by traveling to Austin, traveling to Hawaii, people.
Yeah. And then different things you can show it.
Yeah.
Price is
Yeah.
almost the important thing for me. Every time.
Yeah. Next, I will present my second work. The full title is Shades of Representation, Auto Detection, and Perception of Skin Tone Diversity in Visual Marketing Communication. So for this paper, we know in recent years, especially the past 3 years, like those firms and companies invest a lot in diversity. The general belief is that those diversity not only affect customers' perception of those brands, but even affect their purchase of those brands. And a report from Wall Street Journal also shows that diversity level affects companies' stock performance. So we know in May 2020, there's a social unrest after the murder of George Floyd. So after that, those brands stand out to show their support to the Black Lives Matter event, and they make those announcements on their social media platforms to show their support and legitimacy to those consumers. Specifically, when we look at those media platforms, those companies will post those images like shown here to promote their new products or generate awareness. So the choices of those models, like their age, their gender, their style, can affect people's perception of diversity. We specifically look at the skin tone in this study. It is because skin tone is like less studied in the literature, but it's considered a manifestation of diversity. More importantly, skin tone sits at the heart of colorism. Whether colorism results from the typical beauty standards that favor light skin tones in advertising. So despite years of efforts, it's not only prevalent, but also systemic in those marketplaces. So in this study, we try to address this issue. Specifically, we will ask 3 research questions. First, how can we measure skin tone DI objectively? Here we will propose a deep learning framework. And second, we will ask what does skin tone DI mean to people? Here we will do experiments to understand what skin tone diversity means to people. With those 2 methodology, we will next do an illustration. How is skin tone DI represented in visual marketing communications? Here we will apply our methodology to social media data. So we're discussing skin tone DEI. So what is skin tone DEI? So in traditional study, in previous study on skin tone or in the discussions of those colors, they usually focused on the brightness, that is the lightness or darkness of skin tones. Here we based on ecology research, since those ecology researchers are first to analyze diversity focused on biodiversity. We similarly propose that skin tone diversity have 2 more dimensions. The first one is richness and second one is evenness. So richness concerns the numbers of skin tone categories included in a set of images, while the evenness concerns the equality of different skin tones in a set of images. If we look at this representation A, we have 2 types of skin tones, light and medium. In representation B, we have 1 more skin tone category that is dark. That means in representation B, it has greater richness than representation A. So for representation C, we still have the 3 skin tone categories, but each category here has a similar percentage. That means representation C has a greater evenness than representation B. So accordingly, we propose a set of diversity indices to measure those 3 diversity dimensions from richness, evenness, and brightness. For richness, like for example, we have the regional richness index, Mahinic index, deviation range. For evenness, we have Gini index, Shannon index, Gini-Thompson, Berger Park index, similarly for brightness. So our first question, how to measure skin tone DI objectively? So our methodology starts from extract the human skin from those brand posted images. So to extract the skin, to try to make it more efficient to analyze those large data on social media, we propose to use those computer vision algorithms called image segmentation. After we extract the skin pixels, in the next step, we do skin tone DI calculations. That is, recall for those digital images, their colors can be modeled by this SHV color system. The H here means the hue, S is the saturation, V is the value, also called brightness. So the value or brightness directly is what we are interested in studying colorism. So in here, we removed the hue and saturation as shown in the fourth figure here, just focus on the skin tone brightness. As we find that some images may contain more than 1 models, so we applied k-means to extract the dominant skin tone brightness in those measures. So in total, we have average measure and dominant measure. As each those brightness values can range from 0 to 255. Similar values really represent similar like skin tone types. So we further characterized those values into very dark, medium, light to very light. And last, we can compute the DIE matrices. And here is a deep closer look at our skin segmentation model. It is an encoder and decoder structure. For the encoder, we select the Swain transformer. For the decoder, we use a Uperlate. To train this model, we used the public dataset called face and skin detection dataset for 3 reasons. First, this dataset contains large number of images, including 4,000 images. Each image is well annotated with the ground truth of those skin pixels. Second, this dataset contains the complete types of skin tones from like those brownish, pinkish, whitish, darkish. So this can guarantee the accuracy of our model in detecting different skin tone categories. And third is those images in this dataset were taken in various lighting conditions like indoor and outdoor. So later on, we will apply this model to social media data. We can have a more like robustness. And to further improve the performance, we apply this data augmentation technique. So in this technique, we manipulate the images in the hue, saturation, and brightness channel. For each channel, we create those variations. The goal is that so those model can learn human skin based on the color information, also based on other information like those texture information. In this study, to remove like those bias, we try to let this model to focus on more like those texture informations, not just focus on the color information. So at last, we have 60,000 images for the model training and testing. And compared to a recent paper published paper, our model achieved a state-of-art performance across the recall, precision, and F1 scores. So this is performance. And after we trained this model, we applied this model to a dataset called Fair Faces dataset. So the goal is to compare skin tone across and within different racial groups to give more motivation of this study. So from this figure, we can see that the vertical axis is the skin tone brightness. We can tell for each racial group, there's a like certain height for those box plus body. That means within each racial group, the skin tone variation can change a lot. And if we look at it across those racial groups, we can see they have overlapping. So this gives us more motivation that the skin tones is different from racial groups. And also skin tones is allows like more nuance and details the representation of diversity compared to just race or ethnicity.
Can I ask a quick question here? So far as I have heard starting this project, my impression is skin tone in this project is really just the picture that you analyze, you extract from each picture, the faces within each image, and you analyze the brightness for that picture. So it's literally just the brightness in the picture, right?
Yeah, the brightness of human skin in the picture.
So the picture analysis, while there has been a ton of literatures, not only in marketing, but also in some other related fields, such computer vision, has already done a lot of research on that. So what do you think your study is differentiated from those? So far I have heard, my impression is skin tone, that what you define in your research is really just the picture analysis on the faces in that picture, and it's only one measure, brightness.
Yeah,
Correct.
that's a good question, Dr. Chen. So actually, there's indeed some studies focus on like detecting human skin from those images. For example, like those US paper here we cited is published this year. So in different researchers, they try to propose different like machine learning models to extract those human skin tones. The goals to improve the performance. Actually, in our study, we used those encoder decoder with transformer model. Our model, you can tell from the performance, our model achieved the state-of-art performance, even better than the recently published paper, the US paper. So for the first research question, we can argue like our model in detecting those human skins can like achieve the state-of-art performance that can guarantee later on, when we apply this model to our social media data analysis, this can give us like more confidence. So
So what I I think what my question really is, it's not about the model that you used in this paper. And what I want to really clarify is to understand what is your contribution in this research in terms of what you addressed is skin tone, but my impression or my understanding so far is really just a brightness analysis within each faces of each image. And the image analysis has been done a lot in existing literatures. So I try to understand. So if my understanding is not correct, so please correct me now. Right. So and also I want to know what is the DEI measure in your study? So two
Okay.
questions.
Yeah, I understand your point here. So, detecting the skin tone is only the start point of our methodology. You see here, our methodology is end-to-end framework. After we detect the skin tones, next is a more interesting part for marketing. That is, from theoretically, we propose those skin tone dimensions here as the richness, evenness, and brightness. So typically, when we do the literature research in marketing, we find that prior researchers solely focused on the brightness channel. They even like didn't discuss the richness or evenness of those different types of skin tones in those images. So here in this study, we try to theoretically to propose that skin tone diversity not just includes only richness, but also people think richness not only includes brightness, but also consumers will think that richness and evenness is also important to him. Later on, we will like do experiments to validate those hypotheses.
So okay, so you are saying in this research, your skin tone measures include not only brightness, but also richness and evenness.
Yeah.
So that I could also associate with those measures or dimensions as the quality of the picture instead of associated with those measures to skin per se within each image, right? So to me, it's, and bottom line is it's still the analysis of images, although you just focus on the faces within each image.
Yeah, we focused on all the human skin in each image.
Your unique contribution is your link this skin tone
to this
compared with
diversity.
analysis with marketing. That's your unique.
Yeah, here actually, yeah.
I think you need to answer the question in a simple and efficient way.
Right. So can you repeat that one? I couldn't hear very clearly from my side. Can you repeat your contribution?
Can you repeat what I said?
Dr. Brand
Yes.
suggested my main contribution here is linking like those computer vision to marketing applications. So later on, I will also show like how we can apply this methodology to more like marketing problems. So in the second and third research questions.
Yeah, I think it's important to, because what Dr. Chen is saying is exactly right. The measurement itself of skin tone or even of skin pixels or faces analysis, that's not new.
Yeah.
Right? And that we're not, I think, because you spend a lot of time at the front end, how can we measure it, those kind of things. What makes it seem like that is the main contribution. But the main contribution is
later
okay,
on.
now that we can measure it, what does that inform us of? And we can see, we do the experiment so that we can understand how do consumers perceive diversity in advertising, and skin tone then is a helpful tool for us to better understand that. More so than just a racial classification. And then we can better understand marketing practices. Right?
Hope Dr. Chen, I will present the second research question here. I will show more consumers understanding to the skin tone diversity. You will see like we have more marketing implications here.
Right. So I think, well, thank you for providing the information. So I think what I want to emphasize maybe is as the same along with other your dissertation committee, which so the computational or methodological contribution is part of your dissertation or your contribution to this to the research field in engineering part. But maybe you could also started to have the mindset to, you know, to present your research. If you want to talk to marketing people, practitioners, and they really want to know what is your funding can help us in terms of marketing, in terms of advertising, and you should not only emphasize your model performances, but also you know, to emphasize the marketing insights that you provided combined with the methodology that you have applied.
Yeah, definitely. Later on, we will actually present more marketing insights. Like,
I think the reason why he present a few related to the computer vision, because one of the committee members, Dr. Hing Wing, is definitely world leading expert in this field. So I think he
yeah.
Okay, yeah, please continue.
Yeah. Okay. So actually here we will answer our second research question. What does skin tone DI means to consumers? So to do this, we conducted this skin diversity perception experiment. Specifically, we applied this collage making approach. Participants here will required to select a combination of images to make a collage. They will need to they were required to create the most diverse and least diverse collage in terms of skin tones. So to create those collage, the repository here is very important. So those participants will need to select images from this repository. This repository should first be like largely loved, so our respondents will not be limited by those image options. Second, in this repository, we also need to control other like variables that could affect people's perception of skin tone diversity, such as those model's age, hairstyle, gesture, and race, etc. So to do that, we create this fact faces repository, including 20 human face identity. For each face identity, we have 2 gender variations, female and male. For each gender identity, we created 10 skin tone variation by only changing the brightness, while maintaining the hue and saturation. So finally, we did 2 pivot study to test the feasibility of our survey and experiments. One conducted within our lab internal members, other with external members on Amazon Mechanic Turk. So finally, we recruited 402 respondents from Prolific. We balanced the gender and age of our respondents when they're making those collages. Interestingly, we find that so remember, we have the most diverse collage and least diverse collage. We perform this PEST test to compare people's evaluations across each diversity index. We find that each index results is statistically significant. And if we take a closer look at each index, we will find that what does skin tone diversity mean to people? We will find that people perceive greater richness as more diverse. They perceive greater evenness as more diverse. In terms of the brightness dimension, they perceive darker representation as more diverse. So here we try to enrich our knowledge in marketing, like what does skin tone diversity mean to people. So later on, we also performed this reliability and sensitivity test to compare like those diversity metrics in each dimension. The goal is to we can suggest the best one for future practitioners or researchers so that they can incorporate those cool methodology in their own research to measure the skin tone diversity across those different dimensions. That would make it more comprehensive. We further explored people's perception bias across those 3 dimensions. Interestingly, we find people's perception of brightness is subjective and biased, like conditioned on their gender and racial demographic. So if we look at the left-hand side figure, recall a larger skin tone brightness value means more lighter skin tone representations. So we find that when creating the most diverse collage, female participants selected more darker representations than male participants. And when doing the least diverse collage, male participants selected more darker representations than female participants. Similarly, we find such heterogeneity across the racial groups. So then, but interestingly, we didn't find like those on a other 2 dimensions, richness and evenness. That means people's perception of richness and evenness are consistent and objective over the demographic information, including gender and race. So this also gives us very new findings that as marketers and advertisers, we can not only like do decisions based on just the brightness, since it's just subjective. We cannot make like one fit for all like decisions. And with this methodology, we applied it to study how the skin tone DI represented in visual marketing communications. We carefully selected 34 fashion brands top ranked in the list index. So the list index just ranks those fashion brands according to their sales, their website traffic. So those top ranked fashion brands can signal their like significant impacts and importance in this industry. And we collected their images posted on Instagram and Twitter on each account. And later on, I will present the results, specifically focus on the monthly posted images. That is, I will aggregate those diversity matrix results over images posted in each month. Across the 3 dimensions, skin tone brightness, skin tone richness, and evenness, those are the curves over the 2 years. We can see that especially after the middle of 2020, those curves has like changes. So to test those authentic efforts, so first of all, those changes definitely could signal those brands, their actions after the murder of George Floyd. So to test the authentic efforts, we apply this Bayesian change point detection method. So we assume there's a change point top somewhere between the 2 year over the 2 years. So before this change point tau, the distribution is a llama distribution, but after that it's a larger llama distribution. Those 2 llama distributions, they have significantly different mean values. So we find that interesting.
So in previous slides, you mentioned people are more sensitive to brightness across different races or something, right? So
yeah,
they're not sensitive to richness and images. But why? I mean, after 2020, you know, the feeling about the richness and images changed.
Actually, the experience is from consumers' perspective. Like they think like skin tone diversity, richness, brightness, and evenness, they're all important to them when making those images. But those figures shows the images. Those images are from brands. It's brands' activities. They made those changes.
They made those. Okay.
Yeah, it's from the firm's perspective here in this figure. So our Bayesian change point detection method finds that for brightness, happening the changes statistically significant changes happened around the April 2020, but for richness and evenness, the changes happened later in July 2020. That means when those brands react to the social movement in 2020, so they first prioritize their efforts in changing the brightness in their social media accounts. They feature more darker representations and keep featuring more like those darker representations along the way. But later on, they consider the richness and evenness in their social media platforms. Recall the brightness channel, as we find through the experiments, it's a subjective perception. That means when brands make those changes on the brightness, they cannot meet everyone's needs. This also gives a lot of interesting findings that there's recently a marketing science paper. They find that those brands support to the Black Lives Matter actually backfire their brand popularity. So our paper gives a lot of interpretation. So with our tool, we can also apply those brands DI position with across those 3 dimensions. See, the vertical dimension here is the brightness, and the horizontal dimension is the richness and evenness. So a larger brightness value means lighter representation, while across the horizontal one towards the right-hand side, it's a greater richness or evenness. So across those brands, we can aggregate their brand positions and obtain the industry standards as shown in these gray circles. So if brands located in the orange area, that means those brands feature more darker representations, greater richness or evenness in their social media platforms. But if brands located in those blue area, that means they feature more lighter skin tones, smaller richness, smaller evenness on their social media platforms. So what marketers can do with those tool? So we know those like similar fashion brands, if they make those decisions on their social media and visual marketing strategies, they not only based on their own strategies, it's like a game theory, they also based on their competitors or the industry standards. So with this tool, they can monitor their own and their competitors' diversity perceptions to react to those like social movements or to make like accommodation to those consumer needs. Yeah, this is a tool for them.
This I also help. I think, I don't know, I think you need to narrow down the domain for analysis, for example, right? So you analyze most of the brand here, but for some brand I know, for example, Air Jordan, right? Because they target more like, I don't know, African American people, because Black people like play basketball. I play basketball too, but you know, compared to Asian and the white people, Black people probably a majority of the consumers, right? So I think you need to distinguish the question from different perspectives. You cannot, I don't know, put all the brands and analyze the trend. I don't know, probably now I don't think it makes sense. Also, probably, I think you need to link the change of the brands with their profit. That makes more sense.
Oh,
to me, right? So
that's nice.
yeah, I don't know if you can get this information first, but if in case you can get this information, probably, you know, the change of the thing.
Probably I report of that.
Yeah, they have a report, right? They have a content report. And so I think that makes more sense. Otherwise, you put all the brands together without any kind of differentiation, you know, like Gucci, LV, I never buy.
Actually,
You know, you also probably divided rich people, middle class people, low income people, you know, different races. In this way, I think that those analysis will make
more
sense,
insights.
right? So, but if you put them together, hammer them together, it's hard to tell. You can analyze the overall trend of the brand. That's true, but it's really meaningful. For example, like Jordan, you know, I cannot change my favorite group of customers at short time. So, you know, I only care about you know, probably a certain group of people. That'll be good enough for me.
Yeah, that makes sense. Actually, right now we try to emphasize that our tool can do these things, but as you mentioned, we can definitely do more, like to explore the heterogeneities across those luxury brands and commercial brands. In our initial round, we actually analyze the difference between those luxury brands, like those Gucci, Versace, compared to those more like commercial one, like Nike and Adidas. So we actually have those differentiations in our earlier round. But right now, when we write it up, like in our manuscript, we focus on more like we try to emphasize, oh, our tool can definitely do those. And actually, right now we're exploring how those diversity indices can affect brand popularity. You mentioned sales, that's one measure that's definitely good. But for most of our brands, it's private companies. We cannot get the like public sales data. So, but right now we're gathering their followers, likes, comments on social media platforms to do more like analysis to see how diversity indices can affect their popularity.
Need to narrow down. Even for the
Yeah.
luxury brands, say for example, probably like Han is gonna buy Armani, but I don't think he's gonna buy Gucci. Because Gucci is too, I don't know.
Well, what's
Too
interesting,
much for him.
what is interesting,
say,
right,
yeah.
is that I agree with your point. It would be interesting to look at, I think if you can map out the target audience in
Exactly.
the same way,
Yeah.
that would be very, but what is interesting is that, you know, with the Bayesian change point detection is that we see that, like, even when we lump all of these together, we see this significant change in the increase in these metrics as a response.
Yes.
Yeah.
So like, it would, and then we would need to see like, okay, if they all do change, for which one does it work and for which one does it not work?
That's
And I
true.
think that would be a very nice follow-up analysis,
Yeah.
and then like split it up like you said. We can talk about this.
Yeah, that's also
Okay.
more meaningful for
For each brand.
For the brand.
Yeah.
Yes, maybe I could add one more comment here. So another data you may want to look at, and I know that it's not that hard to get, is customer satisfaction index. So if you could check if customer satisfaction or some other measures related to from customers' side, it's worth checking to see how customers' perception change or evolve before and after a brand change their position.
That's really a great comment, Dr. Chen, since right now we're considering firm side, but yeah, if we have consumers like satisfaction, that's another side. Thank you so much.
Yeah,
I would
unfortunately,
definitely
like
consider.
the YouGov, right, that we talked about,
Uh,
and forgetting.
they have,
They have this
but they are
information,
too
but
expensive.
they quoted us like $50,000.
Actually, I happen to know this customer satisfaction index can be obtained for free from I think a vendor is called ACSI. When I could send you the related information after your defense.
Yeah, that would
That's
be
so
great.
Yeah,
nice.
you could check with them.
Okay.
Yeah.
Half the price of Dr. Chen.
Yeah, definitely. Thank you, Dr. Chen. So this is a summary of the second work. We similarly theoretically propose those end-to-end tool to assess skin tone diversity across 3 dimensions. So we also theoretically extend our understanding as marketers to those skin tone diversity dimensions. The tool can definitely inform decisions on like brand management, and positioning. More importantly, from the societal perspective, our tool can like foster the transparency and accountability in those brands' actions to combat the colorism in various marketplaces. Later on, this is the third work. The title is Congruence Affects Story Adding Engagement on Social Media Platforms. So in this work, I will focus on the short video advertising and social media advertising. So we know in recent years, especially after the TikTok arrives, the short videos very, very popular. Like even Dr. Han plays TikTok as far as I know. So the most reason is that those short videos are free to access, unlike those subscriptions we need to pay for them to view. But this is free to access. A lot of reason is that as those content creators, it's easy for us to adapt to those like news and trends. Like for example, if some big influencers post something or there's some like big news, they can easily make a short video to promote those things. So from the marketing side, like in the short video, it's saying that short videos are like 2.5 times more engagement than those long form videos. And 85% of marketers believe that short videos are the most like effective ways to do those advertising. So accordingly, the short video ad revenue this year is also projected to cross 10 billion. So it's really a huge market. So specifically in this study, I will look at a short video called Stories. So Stories first appeared on Snapchat in 2013. After 3 years, due to its popularity, Instagram's copied this function in their platforms. So we can see here, those are 2 screenshots of my account. We can see on the top there are circles. Those circles are stories, and has really post those stories. If we click those circles, we can view the post of those stories. Usually when users post those stories, there is more like a social sharing purposes. So they share their daily lives, their events, compared to when we like use YouTube, we usually like just search for some like knowledge. It's totally different purposes. Interesting thing is that for those stories, they will automatically vanish after 24 hours from their creation. So this kind of like ephemerality really like push people to do this engagement because of like those things of fearing of missing out. And those stories are very popular in practice. Like Instagram stories hit like 500 millions in 2019. And brands also engage in those stories, creating 10 stories each month. So due to the popularity, those companies monetize such function by inserting story advertisements between 2 stories. Those advertisements have the same format as stories. It's very short, either image lasts for seconds or a short video. So you can tell from this advertisement sample, we do not have skip button on these advertisements. It's very different from those like YouTube advertisements. There's a skip button on the right-hand side. And also this advertisement is vertical, take up the full mobile screen. So a very interesting question in practice is that we know for a user, they can view a sequence of stories like this story 1, story 2, story 3. Between like 2 stories, there may be advertisement slots. Those slots are fixed in companies like Snapchat. So the question is, for a given advertisement, where should we place it to improve its engagement? In this study, we will look at the contextual effects, that is add context congruence between the preceding viewed story and the current advertisements. In this case, for example, for ad slot 1, it's the story 1. For ad slot 2, it's the story 3. We are interested in whether the congruence between the preceding the prior viewed story affects the ad engagement. We look into 2 types of congruence. One is the content congruence, another is the format congruence. For content congruence, so for example, if we have a food advertisement, should we insert it after a food story, or should we insert it after a long food story, such as this sports story? So for the food story and food advertisements, we call it congruent content category. But for long food story and food ad, we call this situation as incongruent content category. For the format congruence, we specifically for format, we have video or image. So for video or image, we call it congruent format. But for image video or video image, they're incongruent format. So to understand how the congruence effects could affect people's engagement over the advertisements, we propose to build hypotheses based on the process influences theory. So the process influences theory is the ease with which a stimulus is processed. So people love processing ease. It's because it's a more like predictive way. For example, if I took people to a restaurant, I prefer to take him or her to a restaurant that I'm familiar with because it's predictive. I can take in control of those differences. So specifically in our study, the exposure to the story, a priorly viewed story, will assume it can increase people's like processing of the following advertisements, so that leading to a more favorable attitude and engagement. Specifically, we have 2 hypotheses. In hypothesis 1, we posit that a congruent media format can lead to more ad engagement measured by ad viewing time. Similarly, for content, we assume that congruent content can lead to more ad engagement. So to answer those hypotheses, we collect a first-party dataset from Snapchat with over 6 million people engaged in this study. Each observation includes the people's viewing of a story and followed by advertisement. We considered 17 content categories. Those 17 categories are the most popular ones on Snapchat. Also, those 17 categories are used on YouTube. On YouTube, there's a data set, so they also use those categories. For the tag of those content, like whether they're gaming or beauty, we use the manually annotated results in the Snapchat company. With this real world data, we really want to.
Question.
Yeah.
So you have the individual observation. How many different ads were there?
That's a good question. We like report those statistics in our paper, but I don't really remember that. Yeah. I will check that for you after my defense.
Yeah.
So with this real world observation data, we really want to do this causal inference. That is, we try to infer the effect of the format or content congruence on people's ad engagement behavior. So to do causal inference, there's a famous framework called named Rubin potential outcome framework. So for each individual, if this individual experienced treatment, like we assign him or her to the content congruent or format congruent group, we call it the result, the engagement result here is the yi1. If this individual does not experience the treatment, the outcome will be yi0. So the treatment effect here is a difference between those outcomes. But in reality, we cannot observe like two outcomes for one individual, since one people like can only experience one thing at a time. So this is a fundamental problem in causal inference. So what we can do is that we can find a similar unit for a treated unit. Say if a individual received the treatment, we can find a similar unit like this treated unit from angles like those gender or age. So this is called mention. In this study, we used another strategy called weighting. Since when we do mention some units, we cannot find a good like pair for this unit. So this will need to the loss of samples. To maintain the full sample size, we use this weighting. Specifically, it's called propensity weighting. The propensity score is the probability that each individual receiving the treatment. So here, as we giving a set of covariates like those gender, age, we can predict the probability this individual I receiving the treatment. As in our study, our two treatment variables, the content congruence or format congruence, they're both binary, either receive the treatment or not. So we can apply this logistic regression as the function f here to predict the propensity. With the probability, we can compute the weights here, W, for treated and for control units. To come to like say our propensity weighting is valid, we need to do this validity check. We apply the standardized mean difference. It's similar to t-test to compare whether our weighted units are comparable or not. Another assumption in this causal inference framework is ignorability. That means, as I mentioned, when we try to find a similar unit, we can consider a gender and age, but we need to consider all the confounder variables. That is, recall here, our dependent variable is add viewing time, our treatment variable, treat format or treat content. So if a variable affects both dependent variable and treatment variable, we call it as confounders. So in this causal framework, we need to control all the confounders we know. So here we need domain knowledge to like select which variable we should include in our analysis. So specifically, we have 32 covariates across 4 perspectives: user characteristics such as gender, age, ad characteristics, those visual complexities, face presence, brightness, ad categories, etc. And also we have contextual factors, situational factors, whether those individuals using Wi-Fi to view those stories or advertisements between like compared to cellular Wi-Fi may have a more like fluent viewing experience. So some of those covariates will apply those different computer vision to do the feature extractions. And then we can apply this logistic regression to get the weights for us. Here is our statistic model to answer the two hypotheses. To answer the format congruence effects, we built this model. The coefficient beta 1 here is our focal coefficient. If beta 1 is positive and significant, that means congruent format can generate more ad viewing time. To explore more heterogeneity between image ads and video ads, we add this interaction here. In study 2, we focused on the content congruence. Here is a similar model. The beta 2 here is our focal coefficient. If it's like positive and significant, that means those content congruence can generate more ad viewing time.
Is the content congruence simply the category? If it is the same category versus
Yeah.
a different category?
Yes, yeah.
So you can think about for the 17 categories, right? You could think about,
Yeah.
you know, one thing is it being exactly the same, but then there's also almost like a distance metric, right?
Oh, yeah, like those cosine distance embedding, right?
Yeah.
Yeah, right now to make it simple, we just look at the tags of those contents. While doing this experiment, research, actually, I consider those like natural language processing to do those embeddings. But yeah, finally we decided to just use the simple way. So here is the main results. First, let's look at these figures. For the content congruence, the purple bars, we can definitely tell that the congruent content have more average ad viewing time compared to the incongruent content. But for the format study, if we look at the left-hand side, the 4 bars, so we can tell the dark line here shows the average ad viewing time in the content congruent versus incongruent group. We can tell in the content congruent, the lines like way higher than that in the incongruent one. That means that support our hypothesis, like format congruence can generate more ad viewing time. But specifically, when we look at the video ads or image ads, for example, if we look at the video, image video, we can tell that for video ads, actually incongruent video generate less incongruent incongruent format for video ads, such as image ads, has more ad viewing time than video ads. So here we that's the reason we build the interactions. So when we look at the estimation results here, the main results, I only include the main results here. So in the main column, we find the coefficient is not significant, but in the moderation column here, we find that the treat format is positive and significant, while the treat format plus video ad is negative and significant. That means video format congruence can increase the ad viewing time, but image format congruence can decrease ad viewing time. So this is a more granular analysis on the video ads or image ads level. But for the content congruence, the estimates are both positive for either video ads or image ads that support our hypothesis too, that content congruence increases ad viewing time. Yeah.
So this is the ad viewing time, right? So does it mean in seconds?
Yeah, seconds.
So does it mean that if you have congruent content, you get 0.2 more seconds of engagement with the ad?
Yeah.
Okay. And do you have any idea what that if that's good or bad?
So first, from statistical angle, since it's significant, that means it's good. From the practical angle, we compute the average ad viewing time across all ads is about 1.5 seconds. So definitely, for example, this 0.2 is a lot, right?
And then, but I can imagine that like the outcome variable. Is that normally distributed or is it like has a long tail?
I think it's the long tail. Most you see those ad viewing time is most of them like just as I mentioned, the average is like 1.5. So it's like this.
So then shouldn't you log transform it?
No, just want to give a more like direct implication on the ad viewing time. So we applied the original variable here.
Yeah, but it can be influenced by.
That's a good question.
Like
yeah,
congruence or and there's a bunch of consumers that like
we
looked at it for
we actually did like those tests. So in our study, we have over 6 million data with such a large sample size. We don't assume the residuals of follow a normal distribution. That's not basically the assumption of linear regression, but that's not the case for us since we have large sample. So that will be a lot problem. Yeah.
And then another thing with the dependent variable, right? What if I click on the ad, but I click very quickly? That would be, it's negative for it's a negative effect, but it's a positive outcome for the company.
Oh, you mean a lot other behaviors like click?
Yeah, but like now you measure click, right? And so maybe someone watches for a long time and then it's like, okay, I'll keep going. Right? Like I go to the next story. And maybe someone is like, oh, I like this, and I click, and then the ad viewing time is a lot less.
Oh, you mean maintain it, like just loop it over?
That means if you cancel the video, that not necessarily means a bad thing. If you're really interested in the products, right? So I directly click within probably 0.2 seconds. I check it. Okay, I'm very interested. For example, the sneaker, probably I have a long interest.
Oh, you mean like
I want to buy it? Probably it's good.
Okay. Oh, I see your point.
Your outcome variable, right?
Yeah.
If it's engagement or if it's viewing, then maybe that's positive. Right, but then if a click comes after someone really likes it, and it comes like early in the video, then you would observe a very short time.
Yes. Yeah.
But a very successful outcome.
Yeah. Those clicks through actually is a lot of good measure that's more close to the purchase, the final purchase, right? When I do this research, we actually consider those click as a loser dependent variable, but we didn't find very interesting results. So just solely focused on ad viewing time. Since in company, they really care ad viewing time. That's a core metric. They charge those advertisers. If you look at it longer, I charge you more.
So I would put that in upfront when you motivate your dependent variable. Because
Yeah,
if that's
yeah.
what they care about, if that's what that makes them money,
Yeah.
then this is a very important result, right? Because,
Okay,
and then
okay.
you can put this, if you can put this into dollar figures,
Ah.
like you really sell the paper, because it's like, okay, on average, the congruent
Okay.
2.2, this equals
Translate.
$50,000.
Oh
Well,
my
then
gosh.
it's like, great, and then nobody cares about the click.
Okay.
But now we wonder, I think we wonder about, okay, what if a very short video and a click, does that
Okay.
mean lead more revenue or less
Yeah,
revenue?
that's a good point.
Do you guys have the data that how many people click?
We have the data, but that's another data set I analyzed. We do have that, yeah. So
Yeah, I think you just put the data in another parameter into your.
Yeah,
yeah,
and
You know, people show me the running.
yeah, I think, like.
let me
if you
discuss
talk
with
about-
him.
No, if you talk about like this being important for marketers, right?
Yeah,
All that marketers care about in the end is the bottom line, so.
yeah,
Yeah.
makes sense.
Yeah.
That's good. So for summary, in this work, we also apply various
Before we
computer.
go to some example, another question.
Yeah.
I think in general, the distribution is gonna follow Gaussian. Are you
Ad
sure
viewing time?
Is it gonna have a long tail?
It's not very long since there's a cap, like the maximum is up around 3 minutes. So, but most
I think the distribution should follow Gaussian, because I don't know, most people tax the advertisement for.
Mm.
There is screen people click very quickly, there are people watch the long advertisement video.
I thought it's Gaussian, always some kind of, I don't know.
it's actually we
I
plot
think
the
it's
figure.
long-
It's
I don't
it's
think
not
it's a long
Gaussian,
tail,
It's not
because
Gaussian.
Yeah.
if you think, you look at.
but it's okay for analysis since we have a lot of
So the
data.
mean you said was 1.5 seconds, the standard deviation is 3.5, and then the max is 300, is 180.
180. Okay.
Yeah,
Yeah.
I think so.
Yeah.
So a summary, we similarly apply various computer vision to extract the extensive set of features as the covariates in our causal inference framework. We applied the probability weighting for a causal analysis. Our study also enriched the literature in marketing on 8 context congruence, and specifically we investigate 2 types of congruence. More interesting thing is that for process and fluency, we find in the literature, most researchers do lab experiments to like confirm those. But in our case, we extend our understanding in the real life social media platforms. Definitely our findings can offer insights for those advertisement ranking and recommendation systems for those companies. As for conclusion, so basically I apply those machine learning deep learning algorithms in address marketing problems, especially focused on unstructured data analysis. So in work 1, we focused on online advertising, apply object detection and eye tracking. In work 2, we apply image segmentation to study those skin tone diversity. And in work 3, I more apply those data science and causal inference to analyze those practical contextual effects in social media platforms. As for this is a publication so far, including my journal, working paper, and the conference paper. And in the future, I will first submit the skin tone diversity paper and social media paper to GMR, Journal of Marketing Research, early next month. In the future, I will explore more application of artificial intelligence and machine learning in marketing. So for example, recently we obtained this T-Vision insights data with Dr. Chen and Dr. Han. So this is a very cool data set. So this company, they mounted those eye tracker in the room, in those like TV you see here. So those devices can not only attract people's eye tracking, eye fixation, but also they can detect your faces where you are this one or the other one, whether you are the people in this household or you are just like those guests, for example. So with this data, it's very complete data set. We can definitely apply those like machine learning, such as double machine learning, to analyze those like congruence effects between TV programs and the commercial ads. Similarly to we applied the analysis in social media advertising. So this is one case. For those double machine learning, for example, if we have the outcome here, this is the Y outcome model. We also have the treatment model. In traditionally, we apply those like logistical regression to do those predictions. But in double machine learning, we can apply more complicated like machine learning algorithms, like those neural networks, to do those predictions. Since in this case, it's also called inference, but it's totally different framework. And as this dataset is the time series dataset, we can also apply this dynamic, we can also apply this called reinforcement learning framework. Since our dataset is time series, we can come for reinforcement learning, we have a very crucial name, the action. So over time, we can make those assignment in the congruent or incongruent. Over time, we can optimize these strategies over a certain time to find the best advertising strategies. And also a lot of the work is the effectiveness of those artificial intelligence generated content in marketing. So AIGC is really hot in since last year, November last year, the publication of the ChatGPT, the first version. In marketing, it's very hot nowadays. So how we can understand the AIGC, how those AIGC affects those effectiveness compared to traditionally those marketers generated content. So it's very interesting for future work. Yeah, that's pretty much all the presentations today. Thank you so much everyone for your attention and listening.
Wen, I'm sorry to jump. A quick question, a correction. So T-Vision data is not eye tracking.
Okay.
That didn't track eye.
Oh, it's not eye tracking?
It's not.
Okay, but they have the attention measures, right?
But it's not eye tracking. Just a quick correction.
Okay, yeah, sure. You can stop the recording.
I think let's continue until answer all the question.
Okay.
Any other question? Dr. Hin, do you have any question? Dr. Wen?
Yes. So very good presentation, and I like the talk a lot. Could you send me the video after presentation so I can look at it again? One question I have is that how do you, when you compare the desktop versus mobile, I mean, what type of normalization we need to do in order to make sure the comparison is meaningful? Because mobile user, they usually on short attention, and usually when you see there's no attention to the ads, but mobile user, they have very short attention on the screen, whereas desktop people sit at one place, maybe they look at it more. So what type of normalization important and you have done and haven't done to make this a meaningful comparison?
Thank you so much, Dr. for the question. So in the study one, we do the eye tracking. Actually, I saw in marketing, there are researchers use normalization, such as they normalize those eye fixation counter duration by the size of the areas of interest, like the size of the images or text. They just normalize by the size. Yeah. I mean, shouldn't we also normalize by, say, the maximum duration of attention? For a certain, the duration. For each person's like they use the different time, right? When we do shopping, like one person may use like 3 minutes, another person may use like 10 minutes. So definitely we in my research, we control this shopping time. That's very. I see. Okay. Okay. Good. So for the causal inference, have you tried other methods rather than propensity score and the things you presented there, and why not compare it to other more robust method? That's very good question, Dr. Wen. So in marketing, there's a convention, like we use propensity weighting. That's more like acceptable to those researchers. But double machine learning, as I mentioned in the last slides, it's very popular, I know, in machine learning community. And I observe like only a few people starting to apply it to marketing. Double machine learning is definitely more powerful than those like propensity weighting, since we can apply those complex neural network in predicting the outcome or treatment. So I will definitely in my following work, I will use this double machine learning since it's so fancy. Yeah.
Okay. There's a even for propensity score. I mean, there's a method that use neural network for estimating propensity score. Maybe it would be a straightforward extension of what you do and perhaps make it a bit more sophisticated and robust. I can send you the paper.
Okay,
Yeah.
thank you so much,
And
Dr.
you include that. Yeah.
Yeah, definitely.
Okay, well done. Please send me your video so I can also look at it. There's some content I like to see again. Thanks.
Sure, sure. I think I will upload on the YouTube and then we'll send you as soon as possible. Okay.
Bye.
Thank you.
Okay. Any other question from the audience?
No, I asked all the questions.
Okay.
Yeah.
Yeah.
Dr. Chen and Dr. Wen, may I have a picture with you? Like, you can be online.
Yeah. Maybe after.
Yeah, of course.
Yeah.
Oh, you're discussing
So no, the thing that we
Okay, okay.
Yeah.
So, okay.
Happy before, sad after.
You don't know whether you have